So guys, let's do question number 4. It's under risk and return. So an investor is considering two risk assets, asset A, asset B, with the following probability distribution of returns. So we have economic state, when the economy is in boom, when the economy is normal, and when the economy is in a recession state. So the probabilities have been given for each state: 0.3, 0.5, 0.3. The return on A when the economy is boom, the return on A when the economy is normal, and when the economy is in a recession, which is 4%. Same way here, the returns on B: 25, 15, and 5%. So the investor forms a portfolio with 60% in asset A, 40% in asset B. So this is the weight or how much the person is investing. So he's investing 60% in asset A, or the weight on asset A is 60%, which is 0.6. Then the weight on asset B is 40%, which is 0.4. So what are we required to do? A, calculate or compute the expected return on asset A and asset B. Okay, so let's find the expected return of asset A and asset B.
So finding the expected return on assets is not hard. It's simple. So we can start with the asset A. So we are answering question A, question 4A. Okay, so where we are saying let's start with computing the expected return on asset A. So what is the formula for finding the expected return? So expected return is given by summation of so it is summation of the expected return on the return on asset A, then we are multiplying by the probability of asset A. So we are going to be adding them. So the return on asset A with the probability when the economy is in boom, then plus we just keep on going. So like in the question, we have seen that the return on asset A when the economy is in the boom state, it was 18%. So what are we going to say? We are going to say 18%. We are multiplying by the probability on asset A, which was 0.3. Then plus, what about when the economy is in boom? What is the expected return on asset A? So the return, what is the return on asset A? The return is 12% times the probability 0.5. Then plus, what is the return when the economy is in recession? The return is 4%. We are multiplying with the probability, which is 0.3. Okay, so I can multiply this and see what it's giving me. So this is giving me 5.4 plus 12 times that, it's giving me 6. Then plus 4 times 0.3, it is giving me 1.2. So since expected return is summation, I'm just adding all these. It's giving me 12.6. So this is a percent. We can put it as 12.6%. So this is how we find the expected return. It's just summations of the return times their probabilities. Okay, so we can go to asset B. So for asset B, we are doing the same. We want to come up with the expected return. Okay, so what did we say? Expected return, it is just summation of the return on B, then we are multiplying with the probability of B in all the 3 states of the economy. So what was the return on B when the economy is in boom? So the return on B was 25%. So we are saying 25 times the probability is 0.3. Then we are going to say plus. When the economy was normal, what was the return? Is 15% times probability 0.5 plus. When the economy was in recession, the return is 5% times probability 0.3. So we can multiply and see what these are giving us. So this is giving me 7.5. Then here I'm also getting the same 7.5. Then here it's giving me 1.5. So I can add these 3 and see what we are getting as our expected return. So it is giving me 16.5%. So this is the expected return for asset B. Okay.
Then we go to question B. So for question B, they are asking us to calculate the expected return of the portfolio. So you have to be careful. Expected return of the portfolio is different from the expected return of asset A and asset B. So let's find the expected return of the portfolio.
So question B, we are trying to come up with the expected return of the portfolio. So expected return of the portfolio, we can say expected return of the portfolio. So this one is just given by, you have to multiply the weight on each asset times its expected return, then you add them. What am I saying? The weight on asset A, then we are multiplying with the expected return for asset A, then we say plus the weight on asset B, then we are multiplying by the expected return on asset B. So that's how we find the expected return of the portfolio. You multiply with their weights and their expected returns, then you add. So what was the weight on asset A? So for asset A, we saw in the question that we are investing 60%, so that's the weight. So we are going to say 60% in terms of decimal points is 0.6. We are multiplying by the expected return on asset A, of which we already found here on top. It was 12.6. So 12.6. Okay. Then plus the weight on B. So the weight on B here, we already know it's 40%. So in terms of ratio, it's like 0.4. Then we are multiplying with the expected return on asset B. So the expected return on asset B, we have 16.5% here. So we are just replacing 16.5. Okay, so we can multiply these two in this side, then we see what we are going to get, then we add. So when I multiply here, it's giving me 7.56, plus when I multiply this side, it's giving me 6.6. So when I add these two, it's giving me 14.2%. So 14.2%, this is the expected return of the portfolio. That's what we are supposed to do.
Then question C, they are asking us to calculate or to compute the standard deviation of each asset. So let's use the formula for standard deviation we find for each asset.
So question C, we are coming up with the standard deviation of each asset. So we can start with asset A, we go to asset B. So we want to start with asset A. So the question we can ask ourselves, how do we calculate the standard deviation of an asset? So standard deviation of each asset is given by this. It is just the square root of, you need to say summation of the return on asset A minus the expected return on asset A. Then you have to power this, then you say you multiply with the probability on asset A. So we are saying it's the standard deviation is given by summation of the return on asset A minus expected return of asset A to the power 2 times the probability for asset A. Okay, so let's do that. Let's write and see what we have. So we already have these things, we are just putting. Okay, so we can start. What is our return on asset A when the economy is in boom? So our return on asset A was 18%, then minus the expected return. The expected return for asset A, we found 12.6 to the power 2. Then we are multiplying with the probability. So the probability when the economy is in boom, what do we have? It's 0.3. Then we say plus, we go to the next state of the economy, which is normal. The return on asset A is 12%. We are subtracting by the expected return on asset A to the power 2. Here the probability is 0.5. then we say plus when the economy is in recession, our return is 4, then the expected return is constant, the one that we found, to the power 2, then probability is 0.3. Okay, so we have that. Then we can calculate and see what we are going to have. So what am I doing? I'm just saying 18 minus 12.6 to the power 2, I multiply with 0.3. So what I'm getting here, it's giving me 8.748, plus here I do the same, 12 minus 12.6 to the power 2. The answer that I get, I multiply with 0.5. So here it's giving me 0.18. So I have 0.18. Then plus I do the same here, it's giving me 22.188. okay, so then I can add everything that I have here. So when I add everything, it's giving me 31.116. Then the square root of that, the square root of that, it's giving me 5.58. So these are percentages. Then yeah, so this is my standard deviation for asset A. Then we go to asset B. We are doing exactly the same things, but just using the information for asset B. Okay, so what is the standard deviation for asset B? We said standard deviation is given by summation of the return on asset B minus the expected return for asset B, then we are multiplying by the probabilities here, not forgetting to the power 2. Okay, so let's do that. So we can put them. Okay, so what are we having? So when I put, what we are going to be having is when the economy was in boom, the return is 25 minus expected return for asset B, it's 16.5 to the power 2, probability is 0.3. Then plus in normal, it's 15% the return minus 16.5 to the power 2, the probability is 0.5, plus when the economy is in recession, what is the return on B? These things we are getting them from the question on the table. The return is 5% minus C. Expected return on B, this we just found, was 16.5. Then we set to the power 2 times the probability. Probability is also coming from the table. Then yeah, I can multiply what I have and see what it's going to give me. How am I doing that? I'm just multiplying. I'm just subtracting this to the power 2. I multiply by 0.3. So what I've gotten for the first one, after I do that, it's giving me 21.675. Then plus the second one is giving me 1.125. Then plus this one is giving me 39.675. okay, so this is what I have. Then I can add everything and see what I'm going to have. So when I add everything, it's giving me 62.475. Then square root of 62.475, it's giving me 7.90% as our standard deviation for asset B. So yeah, that's what we are required to do.
Then we can go to question D. So question D, they are saying calculate the coefficient of variation for each asset and advise one you would go for. So we want to find our CV for each asset, then we advise which one we can go to. So coefficient of variation, it just shows how risk the project is. So yeah, the one with a bigger coefficient of variation, it means it has a higher risk. So we cannot choose, we can better invest in the one that has a smaller coefficient of variation.
So let's find the coefficient of variation for asset A. This is question number D. So coefficient of variation, or CV, for asset A, what is the formula for finding coefficient of variation? So this is simple. It is just the standard deviation of asset A then you are dividing by the expected return of asset A. That's how we find the coefficient of variation. So what is the standard deviation of asset A? We found 5.58 there, so we are just putting 5.58, then over what is the expected return on asset A. We already found, I think it was in question B or C, what we found was 12.6%. Then we can divide the two and see what we are going to have. So this is giving us a 0.44. So this is the coefficient of variation for asset A. Then we can do the same for asset V. Let's find coefficient of variation for asset B. So coefficient of variation, what are we saying in terms of the formula? So we are saying coefficient of variation is given by standard deviation of asset B over the expected return of asset B. What is the standard deviation of asset B? We have 7.9% here, so we can say 7.9. Then we are dividing by the expected return. For asset B, we found it was 16.5%, should be in question B or C. Then when we divide, what are we having? We are having 0.48. So the question proceeded by saying advise which one you could choose. So when you say question asset B has a bigger coefficient of variation while asset A has a smaller one, so this means that this one has a higher risk. So if you're an investor, you are going to be scared to invest into this one. Therefore, we are going to choose asset A, which has a smaller coefficient of variation or a smaller risk. So what am I trying to say? I'm saying that for asset B, what can I say? Now I'm writing stocks. Hey, so we are saying for asset B has a higher asset B has a higher investment risk. So asset B has a higher investment risk of, what did we find? 0.48. So we choose asset A. So we choose asset A, which has less investment risk. Which has less investment risk. Which has less investment risk of what did we find? 0.44. Okay, so we have advised which one to choose. So we have advised to choose asset A since it has a smaller investment risk.
Then for question E, they are telling us to compute the covariance and the correlation coefficient. So here there are two questions. We are going to calculate the covariance, then we go to the correlation coefficient.
So question E, we are trying to find two things, the covariance and correlation coefficient. So the covariance, which we can denote by that, so the covariance for the return on asset A and the return on asset B, this one is just given by summation of the probability. Then we are multiplying it with the return on asset A minus the expected return of asset B, the expected return of asset A. Then we multiply with the return on asset B minus the expected return of asset B. Okay, so let me just say once more. So the formula, covariance on return on A and B, we are saying it's given by summation of the probability times return on A minus expected return on A, return on B minus expected return on B. The return on A and return on B, we are getting these ones from the table. Expected return on A, we already found, I think, in question B or C, even this one. So yeah, we can just replace what we have since it's summation. By saying summation, meaning we have to do this when the economy is in boom, and also when the economy is in normal, and when the economy is also in recession state. So let's start with when the economy is in boom. So what is the probability? We have 0.3. Then what is the return on A? It's 18%. Expected return on A, we already found this one was 12.6. Then we are multiplying with the return on B, okay, which is 25% when the economy is in normal, minus the expected return on B, which is this. So we are saying plus, we go to when the economy is in a normal state. So what is the probability? We have 0.5. Then we are multiplying with the expected return on A when the economy is normal is 12 minus the expected return on A is 12.6. We are multiplying with the return on B when the economy is normal is 15% minus the expected return on B, it is 16.5%. So because of the space, we can add here and say plus when the economy is in recession. So I'm just going to write down here. So what do we know? Our probability is 0.3. Then what is the return on A? Return on A is 4% minus the expected return on A, 12.6. Return on B in recession, it's 5% minus expected return on B, 16.5. So I can multiply here what I have, and also here, and also here. Then we see what we have, we add them, we find the summation. Okay. So when I multiply everything here and add, it's giving me 13.77. Then plus, I do the same for the normal state, it's giving me 0.45. Then plus, I do the same when the economy is in a recession, it's giving me 29.67. Okay, so I can add, my covariance is 43.89. okay, so this is how we find our covariance. Then the question also asked us to find the correlation coefficient. So how do we find correlation coefficient? So for correlation coefficient, let me just write here. The question also asked us to come up with correlation coefficient. So for correlation coefficient, this one is found just by saying the covariance of A and B. So the covariance on A and B, of which we have already found 43.89, then we have to divide by the standard deviations of these assets. So we are dividing by the standard deviation of asset A by multiplying with the standard deviation of asset B. So we can do that and see what we are going to have. So what do we have? On top we have 43.89. Then down we are multiplying the two standard deviations, of which we have 5.58 for asset A times what did we find for B? We already found these ones. I think it was in question 2. We found 7.9, I mean in question B. So yeah, on top we can write what we have, 43.89. Then down we can write what we are going to find after multiplying these two. It's giving me 44.08. So when we divide, what are we finding? It's giving me 0.9956, which is just a positive 1. So our correlation coefficient is positive 1. So that's what we are supposed to do. Okay, then we can go to the final question.
Why diversification reduces risks? What happens if correlation is positive 1? 0 or -1, and why portfolio risk is usually lower than individual asset risk. So like we have completed for question E, we found +1. So this is about theory. I'm going to write what I think is true. Of course, it's by researching. So yeah, even you can research what you like and you put.